Okay, Mr. Phil here, and this is the first video in my division series. I chose this series specifically because I found that long division is probably the biggest hurdle that most elementary school students will face in their time in elementary school. So I thought we'd build some skills starting with something simple. And I'm going to call this part simple division because we're going to start off with using multiplication facts that hopefully students have memorized, and we're going to relate the idea of division to them the same way. And I would say it's very effective because hopefully students have learned that subtraction is just the opposite of addition. And in the same vein, division is just the opposite of multiplication. So what I like to point out to students often is you see these numbers 18, 6, and 3. You see those exact same numbers in a times table, it's just they're backwards. In a times table, you would see 6 times 3 equals 18. So if your student has, or you have, your multiplication, your single digit multiplication tables memorized, well then guess what? You technically already know then the division facts because they're the same numbers, they're just presented in an opposite order. Of course, we could always see something like 18 divided by 3. If the 3 becomes the divisor, then your quotient ends up being 6 instead. These just switch places. The real challenge is what happens when we start to see that, okay, in division, not everything can be always evenly divided. Like this example here where we say, okay, 18 divided by 6 is 3. Well, what's 20 divided by 6? So if we erase the question mark, we're going to start to see and how to think about this. What I like to tell students is that exact fact. Sometimes we cannot divide or get an even answer when we do a division problem. Our goal is we want to still use our multiplication facts, but we want to get as close to this dividend here, or the number we're dividing into, using multiples of the divisor. So for instance, I know that 6 times 3, like we just did here, is 18. And if I do one bigger, where I say 6 times 4, that number is 24. So as you can see, using that rule that I said, we want to get as close to this number as we can without going over it or getting a number that's a multiple that's bigger. So you can see clearly 24 is bigger than 20, so we don't want to use this multiple or that answer. So that means that 3 is still the same multiple that we want to use for the 6 multiplication table. And that's going to get us to 18, but we're not quite all the way there to 20 yet. So you can either tell your student or yourself that you're just going to subtract to get the remainder of 2. Or what I like to ask a lot of students is, okay, if 6 times 3 is 18, but we want to get to 20, how much is left? Sometimes something simple as just changing the wording that you use can help trigger something in a student's mind. So a good tip is, whether you're the one studying or you're the one teaching or trying to help someone studying, just use different verbiage, use different vocabulary words to see if that makes more sense to them. It can never hurt because you never know what information or what ideas a student has or a person has kind of grabbed onto and held onto for a long time, so you never know. But the idea that we won't always get exactly this number, we got to get as close to it without going over, and then we're going to subtract to see what's left over. The final thing that we're going to do is just show them, okay, well, it's 3 remainder 2. Whatever's left over here, that's called a remainder. Some people in different schools will write a dot or have different symbols, but 3R2 is supposed to signify that we're going to use a multiple of 3 for 6 to get close to 20, but that we still have 2 left over to get all the way there. Let's do another problem with a different multiplication group. So let's say we do something like 35 divided by 8, a little bigger multiplication table there. So again, we're going to say, well, let's say we think, okay, 8 times 5. That's just a guess we're using. So if we write 5 down here, we've got to multiply 5 times 8 to check. And we can already see that 40 is too big for 35. So we cannot use 40 or the multiple of 5 in the 8 times table. So we will erase that, get rid of the 5. We will get rid of the 40 and say, okay, if 5 was too big, let's go down 1 and try 4. What is 8 times 4? Hopefully you can quickly say that's 32. You will subtract to get the remainder, and then write your answer here. Now, hopefully, these steps that I wrote to the side, they're very beneficial to use in the beginning to help your student understand that we need to subtract that multiple to get the remainder. And there's not much more to it. I think the repetition of that is what's going to make sense to them. So in the beginning, don't be afraid to have your student write that number under here. You're going to see a lot of these single digit division problems written horizontally at first because just instead of writing this on a page, you can fit a lot more problems onto a page when you write them horizontally like this over here as opposed to writing the division box. So the important thing is to understand that when they're dividing, we're going to think of our multiplication tables. We want to get as close to our dividend as we can with the multiplication tables of the number to the right of the division sign. I always tell students, whatever number you see to the right of the division sign, that's the number you want to think of the multiplication table facts for. And then what we're going to do is use that knowledge to see how close we can get to 35 using the multiples of 8 without going over it. I think those are some really key talking points to reiterate to your students. And then, of course, the practice. You want to build up speed with this. This is the first step in on the path to being a great long division student. So if you can learn to do these calculations really well, not just being accurate and getting them right all the time, but learning to get fast. What I would say is once you see your student able to do a problem like this, 42 divided by, not 7, let's do 9. If your student can do this, where they look at it and say, okay, 4, 36, if they can do it in their head and get remainder 6, then you know your student has really mastered it. Or if all they need to do is write that multiple 36 here, and then they can get the answer, the remainder here, then you would say, okay, my student, he's really or she has really mastered simple division. I hope you can take these ideas and put them into practice. Good luck, and I will talk to you soon.